The screen you're watching this on right now, it started as ordinary beach sand. Crazy, right? Every day we melt over 100,000 tons of sand into glass at temperatures hot enough to melt gold. But here's the mind-blowing part. This process was discovered completely by accident thousands of years ago. Today I'm showing you how we turn desert sand into everything from your phone screen to skyscraper windows. Hit that subscribe button because what you're about to see will blow your mind. The incredible origin story. Picture this. Thousands of years ago, someone builds a campfire on silica-rich sand mixed with wood ash. When they wake up, something magical happened. They accidentally created the first glass. Those ancient Egyptians around 3000 BC had no idea they'd just invented one of humanity's most important materials. They made small, colorful beads, nothing like the clear glass we know today. Fast forward to 50 BC, Romans revolutionized everything by inventing glassblowing. But for centuries, making flat glass was a nightmare. You'd pour molten glass, then spend hours grinding and polishing. The real game changer comes in 1952, when British engineer Sir Alistair Pilkington has this crazy idea. What if we float molten glass on liquid tin? This single innovation creates almost every piece of flat glass you see today. But wait until you see how we actually do this. The secret recipe. You might think glass is just melted sand, but it's actually like following the world's most precise recipe, and getting it wrong could cost millions. We start with 60% pure silica sand, not just any sand. This has to be incredibly pure quartz from specific riverbeds and rock formations. Finding the right quality is like searching for treasure. But here's the problem. If we just melted pure sand, we'd need temperatures over 1700 degrees Celsius, hotter than volcanic lava. That's where our helper ingredients come in. Sodium carbonate and limestone are like the ultimate wingmen. They lower the melting point from 1700 degrees Celsius down to a more manageable 1600 degrees Celsius, and they make the glass incredibly strong. But my absolute favorite ingredient, recycled glass, or as we call it, cullet. Here's something amazing. That wine bottle you threw away last week could become part of a skyscraper window next month. Recycled glass melts faster than raw materials, uses 40% less energy, and can be recycled infinitely without losing quality. And those gorgeous blue-green tints you see in some glass? That comes from tiny amounts of iron oxide and cobalt. We're talking parts per million. But they transform everything? Here's where it gets really precise. Each ingredient is measured to the exact gram. One tiny mistake in this recipe, and you could ruin an entire batch worth hundreds of thousands of dollars. Now comes the really exciting part. The incredible transformation. Imagine furnaces so massive they never stop running, 24/7 for 10 to 15 years straight. Stopping one of these bad boys would be like trying to restart the sun. Some glass factories receive 5,000 tons of sand every week. That's like having 50 blue whales delivered to your doorstep. This sand gets stored in silos the size of apartment buildings. When it's time to make glass, precision is everything. Each ingredient gets measured to the exact gram and mixed in perfect proportions. Think about it. You're dealing with materials worth hundreds of thousands of dollars, and one tiny mistake ruins everything. The mixture gets continuously fed into these industrial monsters, burning it from 1000 to 1600 degrees Celsius. That's hot enough to melt copper, silver, or gold instantly. But here's where it gets absolutely fascinating. And this blew my mind when I first learned it. As everything heats up, it doesn't just melt. The sand crystals completely break down at the molecular level, gases bubble up and escape, and everything transforms into this incredible, glowing, honey-like liquid that looks almost alive. The furnace has different zones, each with a specific job. There's one super hot zone where bubbles and impurities get eliminated. It's like nature's own quality control system. The liquid glass literally churns and flows like a glowing river, ensuring everything mixes to perfection. And here's something crazy. This molten glass has the consistency of thick honey, but it's at temperatures that would instantly vaporize water. Workers use special heat-resistant suits just to get close to it. But the most incredible engineering feat is still coming. The float glass miracle. What happens next is pure engineering poetry, and I guarantee this will blow your mind. That molten glass at 1100 degrees Celsius, still glowing like liquid fire, flows like honey onto a bath of molten tin. But this isn't happening in open air. Oh no, we're way too smart for that. This entire process happens in a protective atmosphere of nitrogen and hydrogen gases. Why? Because at these temperatures, tin would oxidize instantly in regular air, ruining everything. Here's the genius part that made Sir Pilkington famous. Glass has a density of 2.5 grams per cubic centimeter, while tin has a density of 7.3. This means glass naturally floats on tin just like oil on water, but at temperatures that would vaporize most materials. Watch this incredible dance between physics and chemistry. The molten glass spreads out naturally thanks to gravity and surface tension. It's like watching liquid fire find its perfect shape. This creates a continuous glass ribbon over 3 meters wide, moving 24/7, 365 days a year. It's literally a glass highway that never stops. The tin bath stretches over 50 meters. That's half a football field of molten metal maintained at perfect temperature. And here's something amazing. We can control the final thickness by adjusting the speed and using special rollers at the edges. Want thicker glass for car windshields? Slow it down. Thinner glass for smartphones? Speed it up. As the glass travels across this molten metal highway, it gradually cools and solidifies. The engineering required to keep this stable is absolutely mind-boggling. We're talking about controlling temperatures to within degrees across a 50-meter span. By the time it leaves the tin, the glass is solid but still incredibly hot at 600 Celsius. That's still hot enough to instantly turn water into steam. But we're far from finished. Critical cooling and cutting. The glass enters a special tunnel called a lair, basically a spa for glass. This isn't just cooling. If done wrong, the glass becomes incredibly fragile and will shatter at the slightest touch. The glass enters at 600 degrees Celsius and travels through different temperature zones for hours. Glass has memory. Cool it wrong, and it remembers the stress, eventually cracking days or weeks later. Then comes precision cutting with industrial diamonds. These don't cut completely through. They create tiny controlled cracks, then mechanical systems break the glass exactly along that line. It's like tearing paper, but with materials engineering that's mind-blowing. Every sheet gets inspected by cameras and lasers checking for imperfections smaller than human hair. Rejected glass? It gets crushed and recycled back into the furnace. Perfect circular economy. But there's another way glass gets made that's completely different. Artisanal magic. While industrial production is about precision and scale, artisanal glassmaking is pure art meeting ancient craft. Master craftsmen work with multiple furnaces containing different colored molten glass, emerald, sapphire, amber. They use special ladles to extract the glowing liquid, moving fast because glass waits for no one. Using tools like oversized forks, they mix up to 5 colors on metal tables, literally painting with liquid fire. Then roller machines press and flatten it with millimeter adjustments, meaning the difference between success and starting over. The cutting is done by hand with diamond tools, each cut made by craftsmen who can judge exactly where to score the glass. The result? Unique pieces carrying the individual signature of their maker. Mind-blowing applications? From simple sand to 100,000 tons produced daily, glass literally surrounds us everywhere. Without it, no modern architecture, no smartphones, no solar panels, no fiber optic internet. Next time you look through a window or pick up your phone, remember this incredible journey. Remember those ancient people around a campfire, Sir Pilkington's revolutionary tin float idea, and master craftsmen still shaping glass by hand? Some of the most amazing innovations come from perfecting simple natural processes, turning ordinary sand into extraordinary glass. Drop a comment telling me what everyday object you want to see next. I read every single one. Thanks for watching, and keep staying curious.